Hi everyone, just another example for one like example 3 here where we've got a point and you need to figure out the 6 trigonometric ratio. So we know the point 4, negative 3, if you plot that, it's going to be down in quadrant 3. So it's going to be something like, put on my grid here. So it's going to be quadrant 3, so negative x values, negative y values would be down here, so it's somewhere down there, it doesn't matter exactly. This is just a sketch to help us do our thinking.
Dallas Henry to the main office, please. Dallas Henry, main office, please.
4, negative 3, and then back to the x-axis. So if I think about where this point is and where those sides would be, so negative 4 is on the x-axis, so that's telling me that this is negative 4. This length of that side is negative 4. The length of the side that's parallel to the y-axis would be negative 3, since it's telling me that this point is down 3. Then I need to figure out the length of the hypotenuse, and I can use the Pythagorean theorem for that. So a squared plus b squared equals c squared. I would have negative 3 squared plus negative 4 squared equaling c squared. Save some steps for you. This will be 9 plus 16 equals c squared, which gives you 25 being c squared, and then square root to get 5. So c is 5, which means this side here is 5. As we talked about in class, the hypotenuse is never negative, so that would always be positive 5. My reference angle will be here. So there's the theta. And then as far as figuring out the 6 trigonometric ratios, I know from here, this is going to be opposite over here. This is adjacent, and the 5 will be the hypotenuse. So then I'm just going to use those to figure out the ratio. So sine theta will be equal to opposite over hypotenuse, so negative 3 over 5. Cos theta will be equal to adjacent over hypotenuse, so that'll be negative 4 over 5. Tan theta is going to be equal to opposite over adjacent, so negative 3 over 4, which negative over negative would be positive, so over there I've just got 3/4. And then to find the reciprocal trig ratios, I know from sine I can find cosecant theta would be equal to just negative 5 over 3, so just the reciprocal. So negative 3 over 5 flipped. The negative can't go in the bottom, so I left the negative up with the 5. You could stick it out front too. For cos, it would be the reciprocal of secant theta. So it would be 5, negative 5 over 4. And for tan would be cotan. So cotan theta will be 4 over 3. So there's the 6 trig ratios. And so that's part A. For part B, I have to determine the angle in standard position and 2 coterminal angles. So standard position is not too bad. First thing I'm going to do is I'm going to choose one of these to tell me what that angle is. So my calculator is going to tell me always the reference angle. So I'm going to choose to use sine. So sine theta is equal to negative 3 over 5. Now how I get theta from that is theta will be equal to the inverse of sine, so sine inverse of negative 3 over 5. And then just punch that into your calculator. So I'll turn my calculator on here.
Mrs. Whitcomb, please intercom the main office. Mrs. Whitcomb,
second function sine of, can't see that, can you? Second function sine of negative 3 over 5, which gives me, it says negative 37 degrees if I round it off. The negative tells you it's going backwards, so it's actually in the 4th quadrant, but we really only care about the size of the angle. So the reference angle here is going to be 37 degrees. I'm going to ignore the negative because it really doesn't matter for this, for figuring out standard position. So if the reference angle is 37, so this little piece here is 37, to figure out the whole thing from the initial arm all the way around to this terminal arm, I'm going to have to add 180 to it because I've got 0 degrees here, 90 degrees here, 180 degrees here. So it would just be 180 plus the 37. So angle and standard position will be equal to 180 plus 37, which would be equal to 217. And then for 2 coterminal angles.
Mrs. Taraborelli, please intercom the main office. Mrs. Taraborelli, intercom the main office.
The 2 coterminal angles would be just add 360 to it. So basically you're here and then go around again, all the way around again. So add another 360 onto that. So two coterminal angles. I can write it over coterminal. Are, and coterminal, co meaning like the same, and then, or together I guess, and then terminal meaning the same endpoint, so the same terminal arm. So the same coterminal angles, two angles that end in the same spot, so 217 plus 360 gives me 577, and add another 360 gives me 937, and those are all the same, will all end in the same spot, so they're all coterminal angles. I hope that helps. Sorry for the announcements, you know I can't do anything about that. Have a great day.